going here with probability. Like I said, you have to learn the probability, but I really want to emphasize how this is used in inferential statistics, and basically we're going to really talk about what it means in terms of distributions. But for right now, let's just take a second and talk about the basic definitions. So, an experiment is a planned operation carried out under controlled conditions. If the results are not predetermined, then the experiment is said to be a chance experiment. That it's completely random, it's fair. The result is then an outcome. An event is a combination of those outcomes. And I think I have a little better description for this that might help you out, a visual aid. But so the probability of any outcome is the long-term relative frequency of that outcome. Doesn't mean a whole lot. Kind of just skip through some of this. This part is very important though. Probabilities are between 0 and 1. And that includes 0 and 1. So you can have a probability of 1, you can have a probability of 0. You cannot have a probability of 1.1. All the possible outcomes have to sum to 1. So this is how it was taught to me, and I really like this approach. So think for a second that you're thrown at a dartboard, and you have to hit the dartboard. The probability of you hitting the dartboard is 1, or maybe another way of thinking is if you miss, you get to throw again until you hit. You have no skill at all, so every single part on that board has an equal chance of being hit. Now, it's going to be pretty hard to... So, if you throw that dart, that's going to be an event, right? There's an infinite number of events possible. You could hit just a hair to the left, just a hair to the right. What are the odds that you throw the dart and hit in exactly the same hole as the last one? It's pretty difficult to do. There's just an infinite number of places for it to hit. But if I was to divide the board into, say, the left and the right, then we can say the probability of hitting the left and the probability of hitting the right are your outcomes. And each one would have a 50-50 chance, because we know that we have no skill and this is a chance experiment. This last little bit here is just basic definitions: equally likely, just equal probability. And to calculate the probability of an event A when all outcomes in the space are equally likely, count the number of outcomes for event A, divide by the total number of outcomes in the sample space. So that's, pretty similar to what we just did there. And lastly, law of large numbers. So this basically says that anything can happen on one draw. A lot of things can happen on 2 draws, but you know that as things are repeated, it's pretty predictable what's going to happen. Think about this in terms of a casino, right? The house wins. Everybody knows the house wins. They always walk away with money. They're very profitable. But there's a chance that on one night, one person might get lucky and take home some money. But they know that if they're there every day, law of large numbers will play out, and that person will ultimately end up losing to the house. We'll get into some of these a little bit later. Let's stop there.